installed power capacity and energy generation for each technology in Spain. In this tutorial, I will explain step by step how to create Python code to analyze the differences between the different energy generating technologies in Spain. First, we will look at the installed power capacity and then the distribution of energy demand. In the next section, we will see the average for each technology during the year. And finally, we will look at the energy utilization rate. First, we import the data. We create a cell below and see that we have the data in the data folder. Since it is an Excel file, we need to use the library that loads the data, which is pandas, and search for the Excel function. And now we pass the name of the Excel file in quotes, but it is inside the data folder.
Therefore, inside the data folder, we look for P48.
And here we have the data table, where each row represents the energy generated by a technology in a specific hour, from September 1st, 2022 to August 31st, 2023. To work with the table in the following lines, we will create a variable called df generation, and now I can access it through this variable. Let's go to the first analysis, installed power capacity. I generated this graph with the data table we have here on the electricity network page. In the menu, I download the CSV. Here I open it. I go to the folder where I have the data. I bring the CSV file, and now I open it. We put it on the right. To load the file, we search for the function within the pandas library, and since it is a CSV file, we use this function. Inside the data folder, we pass the name of the file, which is chart. We are going to hide the index, and now we execute. We have an error in parsing because on line 6 it expected 2 fields. However, it saw 7. This is because the data actually starts from row 5. Therefore, we must use a parameter called skipRows to skip the first 5 rows. We save the table in df power, and now we continue cleaning it. I am only interested in the data for the energy type in the power column and in the MIABA2, which is the last registered year. Therefore, we open parentheses power and megawatts. We execute. If I put this, I can see the entire table. We see that all fields have values except here when it starts from the total. Therefore, what we are going to do is remove the missing values, and thus we keep all the rows that have some value. We save it in df power. Let's change the column names. Let's put technology and generation, execute, and we already have the 2 columns. With these, we are going to create this graph, which is a pie chart. Therefore, we go to the chart library called Plotly Express module and look for the PIE function. In the help, it asks us first for the data frame names and values. Therefore, the data frame is df power. In names, we have to pass the column that contains the categorical values, in this case technology, and in the values parameter, we have to pass the column of numerical values. Execute. And here we have the graph with the capacity of each technology. However, there is a total that is not representative. Therefore, we would remove it from df power. Within the technology column, we look for the ones that are equal to total in the rows. We save it in a mask, and now within df power, we only access the mask and we have total. If I want the opposite, we put the tilde and it returns the rest. We overwrite the variable df power and execute. We also have non-renewable and renewable, which are the accumulated values of the different technologies. Therefore, we should also remove them. Here in technology, instead of putting that it is equal to total, I also want to say if it is equal to renewable and non-renewable, but there is a problem because there is no row that is equal to these 3 at the same time. Therefore, the logical condition is not an equal, but the is_in function, which will ask if in each row it belongs to one of the values we place inside the function. Execute. And we see how in df power, we now have the rows removing the 2 we had before, and now we don't see the categories of renewable or non-renewable, and the one with the highest power is wind with 25.2%. There is a property that I used in the original graph called whole, in case you wanted to add a circle. You can reduce it, for example, 0.4, and it already looks like the shape of a donut. If we want to make modifications within the characteristics of the graph, we have to save it to a variable and use the update traces property. For example, if I want the names to appear here, or also the percentage and the number of megawatts, we could pass the text info parameter and tell it that I want label, plus the percentage, plus the value. However, the graph becomes quite heavy. To make the graph a little more readable, we could use these 2 new lines of code in which we tell it that the text is inside the donut, and that, if it does not exceed 12 in size, we hide it. If we execute, we see that the only one that appears is wind. But we could remove, for example, the value and place a smaller number, for example 8, and here we have wind, photovoltaic up to nuclear. Now let's move on to the next analysis, which in this case is the distribution of energy demand by hours. We close the CSV, and in this case we work with DF generation. To calculate the total demand for each of the hours we have here, we could sum the generation based on the hour, and that way, we would take into account all the generation from all the technologies to have the demand. The only thing is that when doing a distribution, we have to count the unique hours for each of the days among all the months of the year. Therefore, when grouping, we have to do it by year, month, day, and hour. We select the column where we will apply the mathematical operation that we are going to sum. We execute, and here we have the total for each of the hours. Instead of working with this type of array, we are going to work with the pandas data frame. Therefore, we use the reset index function to convert it to a data frame. We save it in a variable. We can call it DFF, and now, within the Plotly library for graphs, we look for the histogram. First, it asks us for the data frame, and then the x variable. Therefore, data frame equals DFF and the x variable, which in this case will be the generation.
We execute.
And here we have the histogram. We see that the majority of days are between 25 and 35, with some exceptional days that even have 45 or 16. If I specifically want to see the interquartile range, where the 25th and 75th percentiles of the data are located, I can add a box plot on top. A box plot. For this, we use the marginal parameter and put box. If we come to the box here, it tells us that the first quartile is at 25K, and the third quartile is at 33.5. If you want to see fewer boxes in the histogram, you can use the n-bins parameter with 50, or for example 20, and it will be more reduced. Now let's move on to the next graph. In this case, we have the average generation for each of the hours based on the technology. Therefore, we start with DF generation, and in this case, we have to group by each of the technologies for each of the hours, and see what the average generation has been. We execute. We transform it into a data frame with the reset index function. We save it in a variable DFF, and now, within the Plotly library, we look for bars. In the parameters, first the data frame and then x and y. Data frame DFF, on the x-axis I want the hours, and on the y-axis the numerical variable, generation. And finally, I want to distinguish each of the technologies by color. Therefore, automatically, when passing the name of the column, it will assign the colors automatically. And here we observe how solar energy is only available during daylight hours, when the sun is shining. Finally, let's go to the last analysis, utilization ratio by technology. Starting from the generation table, we take into account that the ratio is calculated with the generated energy, that is, the sum of the generation for each technology divided by the potential energy. How are we going to calculate it? We will group by technology and hour, and we will see which has been the maximum generation throughout the period, which we will take as a reference as the capacity for that technology. Therefore, we start with the potential energy grouping by technology and hour. In the generation, we calculate the maximum. Now we multiply by 365, which are the days of the year, and we add all the generation for each of the technologies. Therefore, we have to group by again at the technology level and apply the sum. We execute. And here we have what would be the potential energy. Now we move on to calculating the energy that each technology has currently generated, grouping by technology and summing all the generation, and this would be the real energy. We execute. We see that both energies have the same index. We have coal, cogeneration, solar. Now we will create a table. Therefore, within pandas, we look for data frame. We open curved parentheses to indicate that it will be a dictionary, where the column name will be the generation for the real energy, and the power for the potential energy. We execute and save it in a variable DFF, and now we are going to remove scientific notation with this line of code. We have to take into account that the generation is within what is calculated in the power. Therefore, in a new column, we should calculate the rest. Within power, we subtract the generation column, and we create a new one, which we will call the rest. Now we proceed to calculate the utilization ratio, which is the generation divided by the total power. We create a new column called ratio. We move on to creating the graphs, and at this point we are going to use another feature of the Plotly library, which in this case is the graph objects sub-library. We put it as Go, and first we create the figure, save it in a variable, and if I call it the blank figure appears here. Now we are going to add a trace. Therefore update trace, and in the first parameter, we have to specify the type of figure we have within the Go library. In this case, bars. First, we put the values we want on the x-axis, which in this case will be the generation that comes from DFF. And since we want them to be horizontal bars, we have to specify that the orientation is horizontal. We execute. And here we see the generation where some reach 61 terawatt hours. However, we do not see the technology to which it belongs. Therefore, we add it in the y-axis within DFF. This part of the table is not technology, but the index because it is on the leftmost side. Therefore, index. We execute and now we see the names of each technology. Now let's create another trace, in this case for the rest column. Therefore, we copy this line and instead of using generation, we use the rest column. In the legend, we are going to change the name so that generation becomes generation. And the same for the rest of power. We execute. Another aspect that we would like to change is the direction of the rest of power, to go to the left. Therefore, we convert the numbers of the rest to negative. Et voila. And finally, we encounter a problem because it is differentiating in height. Therefore, we are going to use a parameter called offset and set it to 0. And here we have the comparison in each of the technologies, which are the most used and which could be used more, but are not. For example, wind power generates 60 terawatts. However, it could be used with 106 terawatts if it were used all day long. Another aspect that may be interesting is to reorder based on the radius. Therefore, in DFF we sort according to the radius column. Although the table may seem from lowest to highest, it may be the opposite in the graph. DFF. We overwrite execute. And here we have nuclear power on top, as it has the best utilization ratio. In summary, I would like to highlight the most important points of this tutorial. First, how we loaded the CSV, which was dirty at first. Then, how we modified the properties of a graph using the update traces and layout functions. Also, the importance of the ISIN function to then filter rows based on certain characteristics. In the next analysis of energy demand distribution, we saw how we calculated with group by and in the numeric column, applied the mathematical operation. Adding a box plot in the figure's margin gives us relevant information because we can see the quartiles. In the analysis of daily average per technology, we saw that we had to do the group by, and when making the graph, we differentiated with color, and automatically the program does it for us. And finally, the utilization ratio per technology. First, we have to think about what type of ratio we want to calculate, and then give it logic in the calculations, which we usually always group. We calculate the mathematical operation in the numeric column, and in this case, we had to do a group by within a group by with the parameter level because we didn't have the data frame. We also have the trick of removing scientific notation. Here you can see that we have added new columns for the rest of the power, as well as the ratio that is formed from the code, which is quite simple. And finally, another way to create graphs through the Plotly library, which is with the sublibrary graph objects, which requires a bit more code, but we can customize it much more. If you want references on how to improve your code discipline, or how to delve into some of the topics we have seen in this tutorial, leave me a comment, and I will be happy to assist you. I would also greatly appreciate it if you give me your opinion on what you thought of the tutorial. If you have learned something new that you didn't know before, and that gives me an idea of where I need to focus more and where I need to focus less. And as a conclusion, if you want to learn how the world works with our data stories, remember to click on this button to subscribe and not miss the upcoming stories. So I really appreciate that you trust us to enhance your professional career with programming. I wish you a good day and see you next time. Bye-bye.